Hi team, today in our video we're going to be going over some of the common mistakes from the test on Monday and the corrections that we did on Tuesday. So two skills that we're actually going to focus on today, and your goal after watching this video will be to have a better understanding of synthetic division and to have a better understanding as well of simplifying radicals. So we're going to start off with radicals, our square roots, and basically go through some of the common mistakes on the test, and hopefully we'll be in a good spot after watching this video. So first, definition for today is index. The index is the number above the root symbol. So when we're drawing a root, for example, the index is the little number that goes right here. A lot of times there's no number there. There's just nothing drawn in. And in that case, we assume it's a square root, or there is an invisible 2. Now, the importance of the index is the index tells us how many numbers we need to circle to remove them. So for example, in a square root, if we had something like 4, when we break down 4 into 2 times 2, because there is a 2 here, we can circle 2 numbers. And those are the numbers that get to go out. So this final answer, because we circled 2, the 2 goes out, nothing is left inside. But what happens if the number is something else? If our index is bigger? So in this case, we have an index of 4. Well, that means we need to have 4 numbers that are exactly the same in order to take them out. If we break down 16 into 4 times 4, that's a pair, 2 of the same number, but 2 is not good enough. We need to get 4. So we'll keep breaking these down. So 1, 2, 3, 4 of the same number. So we can circle it. And that's what gets to go out. Again, there's nothing left over, so we're left with just 2. So the way that we read this is the 4th root of 16 equals just the number 2. The square root, or the second root of 4, equals just the number 2. So think of that index as the thing that tells you how many of the same thing do I need in order to take something out. One more example here. So we still want to break everything down. So 64, we can divide that into 16 and 4. 4 we can divide into 2 and 2. 16 we can divide into 4 and 4. 4 we can divide into 2 and 2. And 4 we can also divide into 2 and 2. So when we do this, again, we need to have 4 of the same thing to take it out. Break down our n to the 3rd power. We have 3 n's, so we're literally going to write down 3 n's. We need to have 4 of something to take it out. So here, 1, 2, 3, 4. And we actually don't have 4 of anything else. So everything else stays in. So for every group, we take a single number out. So that's our friend that gets to go out. Everything else stays in. So the 2, the 2, the n, the n, the n, all of that stays in. So what this ends up doing is we'll have 2 times 2 is 4. We have 3 n's, or that's n to the 3rd power, all inside of our root. We can't change our root, so it's still an index of 4, so we have to make sure to write that index of 4. And 2 is the number on the outside up front. So this is going to be our final answer here. And that's about as challenging as these questions are going to get. The big question we need to refocus ourselves on, though, is what is that index number? And that's going to tell us how many things we need to circle do we need to have the same of in order to take one of them out. Next, synthetic division. When we are dividing, this is the process that we need to follow. So we're going to kind of spell this out for us, make sure that we are feeling comfortable with this before we move on from this skill, because it is an important skill. We want to make sure we're not forgetting it here. So let's start off here. We'll do m squared minus 10m minus 11 divided by m minus 11. Okay, so some steps for synthetic division. First, we want to define all of our coefficients. So what that means is all of the numbers in front of our variables, we want to make sure we have those defined. So what's missing here is there's nothing in front of m squared, but we know that that's just an invisible one that's hiding. So we've defined all of our coefficients, so now we write them. A second step is make sure no skipping degrees. So we go from a second degree term, or 2 m's, to a first degree term with 1 m, to a 0 degree term with no m's. Nothing is skipped, 2 to 1 to 0. If we did skip something, we would need to put the 0 placeholder in. But if nothing is skipped, if we go from a number all the way down to 0, we're fine. Third, we take the opposite of what we divide by, and put that in our box. So here's our box, and we take the opposite of what we're dividing by here. The opposite of minus 11 will just be positive 11, and that's what goes in our box. Step 4, draw your line below the question. So there's our line for step 4, drawing it below. Leave a little bit of space above it, a little bit of space below. Step 5, drop the first term. So our first term is 1, drop it straight down below the line. So 1 is now below the line. And then step 6, multiply anything below the line by the box term. So our box number is positive 11, so we're going to take the thing below the line and multiply it by what's in the box, which is 11. So 1 times 11 is just 11. There we go. 7, combine like terms. So here we have 11 and negative 10. 11, negative 10 together give us positive 1. We're going to repeat step 6 now. Multiply below the line by the box. So below the line is 1. Multiply by 11, we just get 11. We're going to repeat step 7, combine our terms. 11 and negative 11 combine to get us 0. Next, this order is always the same. There is never an exception to this. The term to the right is the fraction. Our next term is the constant, or just the number, no variable. And our next term is the first variable. If we had more terms over here, which we don't, those would be second variable, second power, third variable, third power, but we do not have any terms there. So we can write our fraction, our constant, just keep it as plus 1, put in our first variable, which is m. And the same thing goes on the bottom of the fraction every time. It's what we divide by. So that same thing in red there, that m minus 11, always goes on the bottom of the fraction. And that is going to be your final answer. So these steps always work for synthetic division. Make sure that we're following them pretty carefully. I know it's a lot of things to follow. They don't always make a whole lot of sense, but as long as you have the procedure down, that's what's going to be able to get you credit and get these questions right. As always, questions, let us know, but hopefully we will get a little bit better, a little bit more understanding of these two skills by reviewing them today. Thanks, everybody. Don't forget to turn in your paper with the work on it either to my email or in person. As long as I get that paper, you'll be good for a completion grade.